purpose of our project is to create an energy efficient video streaming mobile app that we will call SwiftDroid. So for some background, there are prevalent multimedia streaming services such as Facebook, Twitter, Pinterest, Instagram, which a lot of users will live stream video from their phone to those social media services. There are also other services that use video streaming. Some of the primary concerns with these are the energy consumption required by the video streams and the signal quality and how that affects the energy consumption of streaming videos. So what we'll try to do is do a joint optimization of the different modules in the streaming process. So some of these different modules are the controller, which is what would monitor the signal strength, the battery level, power consumption, and use that data to determine the settings for other modules like the video encoder, which compresses the video that's being captured, and the transmission module, which transmits the module wirelessly to its transmits the video wirelessly to its destination. So for our project, we will do a coarse preliminary measurement of some data and a quantitative analysis. So we will be recording some data such as the battery level over the course of streaming a video, how much power the Wi-Fi is consuming when streaming that video, and the Wi-Fi signal strength, for example. So our app will record the signal strength and monitor the energy level during runtime, and then we will capture that video, compress it, transmit it wirelessly, and play it back on a desktop computer, and save it also on the desktop computer. So one of the challenges that we face is that there are a large variety of performance influential factors. So these are things that affect how much energy the video streaming is consuming and the ultimate image quality of the video being streamed. We don't fully understand the relations between all these performance factors. Another challenge that we will face is that on current mobile devices, the operating system, in our case Android, doesn't allow us access to modify all the performance factors that we need to modify. And the third challenge that we face is that we have not yet considered other energy resources that might be utilized in the future by mobile devices. There are other energy sources being considered or researched, like solar energy, for example. So for our project overview, we have our controller, which I mentioned previously, and this will be part of the app, and that will monitor the battery energy level of our mobile device and the signal strength, and it will use that to determine quality settings in the encoder. The controller will affect things like what frame rate should be used or the CPU frequency. Now the encoder is again on the phone and is part of the app. The phone will capture the video, the encoder will encode it and transmit that. So for the transmitter module, there are certain factors like transmission power to consider. So the video will be transmitted to a receiver, which is a desktop computer, where it will be decoded. The software we will be using is Android Studio, SwiftDroid, which is an app, PowerTutor, which is another Android app, VLC Media Player, which is a software on the desktop computer, and ImageMagick, which is another software on the computer. The hardware we will be using is a smartphone, a gyrometer, and a computer. We use the gyrometer to determine the best position for this phone to be to have the greatest signal strength. So to implement our project, I previously mentioned Android Studio. We will be using Android Studio to modify code and create our app, and we will use the AVD or Android Virtual Device feature of Android Studio to test our app in a virtual Android device. We use PowerTutor to record the data such as the power consumption, of the Wi-Fi on the phone, the battery level of the phone, and the signal strength of the phone. We use the external gyrometer along with its software to determine the best position for the phone for the best signal strength. We use all the software to get a coarse preliminary measurement of battery level, signal strength, Wi-Fi power consumption, and image quality. So our video streaming procedure involves monitoring the various data I just mentioned and capturing the video from the phone's camera using SwiftDroid or our app, and then compressing that video and wirelessly transmitting it to the receiver, which is the desktop computer, and playing it back on VLC Media Player. Our app will save frames from the source video, and VLC Media Player will save frames in the destination video, which we can use to calculate the PSNR using ImageMagick. In this screenshot, you can see our app and VLC Media Player in action streaming video. So let's start our quantitative analysis with the battery level. So we recorded two 10-minute videos. One video was at 15 FPS and one video was at 24 FPS. So the orange line represents the data for the 24 FPS video and the gray line represents the data for the 15 FPS video. And this is the battery level of both videos over 10 minutes. As you can see, the battery level for the 24 FPS video dropped faster than the battery level for the 15 FPS video. Before we recorded each video, we charged the phone back up to 100% so that this data can be compared. Next up is the power consumption. So on average, we found that the power consumption of the 24 FPS video was greater than the power consumption of the 15 FPS video over 10 minutes. This power consumption is the power consumed by the Wi-Fi module of the phone. Even though there are certain spikes on the 15 FPS video which are higher than the spikes on the 24 FPS video, on average the 24 FPS video had a higher Wi-Fi power consumption. The spikes of low power consumption on the 15 FPS video even out the data. Next up is the signal strength. We recorded and compared the signal strength of both videos to make sure that we were doing a fair comparison of the other data, because if the signal strength of the 15 FPS video, for example, was weak, it would require more power to transmit that video. So by having similar signal strengths, we assure that we are doing fair comparisons of the other data. The dip in signal strength you see here on the left side is from when we were trying to adjust the phone to get the best signal strength. Finally, here is a comparison of the image quality of the two videos. So as I mentioned earlier, both our app and VLC Media Player save frames from the video. So we take the source frames from our phone and the destination frames from our computer, and we calculate the PSNR of each frame using ImageMagick. So as you can see, the 24 FPS video had a slightly higher image quality than the 15 FPS video. One possible explanation of this is that the 24 FPS video used more energy than the 15 FPS video and thus was able to have a higher image quality. So our proposed solution for the joint optimization of all these performance factors and modules is this algorithm. So you take the energy that you want to use to stream a video, let's call that E, and you have the video streaming duration called D. So for example, in our experiment, the video was streamed for 10 minutes, so the duration in that case would be D, or would be 10 minutes. So you take E and D and you divide the total energy you want to use over by the duration of the video to determine the optimum power for the entire video. So this is the power you want at each interval. So after the streaming process begins, at each adjustment interval t of I, so for example, we could have an adjustment interval of every 1 second or maybe every 5 seconds, depending on what would be the best. And at each interval, if the average power is greater than the optimum power that we calculated, then we need to lower the CPU frequency or frame rate to adjust the quality of the video so that we're using less power. If the average power is less than the optimum power that we calculated, then we would want to increase the frame rate or CPU frequency or increase the quality of the video so that we are meeting the optimum power that we calculated. We also have to consider the signal strength. If at any time interval the signal strength is less than the signal strength we determine to be optimal, then we need to lower the quality of the video. Because if the signal strength becomes weak, it doesn't matter how much energy you are consuming, the image quality will always be lowered and the signal strength will act as a bottleneck. So there's no point in wasting energy trying to increase the image quality when the signal strength will bottleneck it anyway. So in this case, in our algorithm, we will be lowering the video quality until the signal strength is at a higher level. So there are many opportunities to use this project, the finding of this project. There are many businesses and services that use video streaming. Things like telemedicine, where doctors can remotely conference with patients in remote areas or places where patients might not have access to a doctor for some reason, and this can help save lives. Video streaming and conservation of the energy in video streaming can be helpful in things like remote education, which can help a lot in places where kids might not be able to travel to school because schools are too far away or something. And this will help the world and society in general. This can also be applicable in environment monitoring, where they use video streaming to monitor certain environments, or for security systems in homes and companies where they use video streaming. So by saving energy there, we help those people save energy on their security system. It can also be helpful in things like monitoring animals, and of course, as we mentioned, there are multimedia services like social media where people stream videos. So as you can see, there are a lot of applications of this project in our society right now. According to Cisco, by 2019, 80% of network traffic will be Wi-Fi and mobile data. So you can see why our project would be pretty impactful in helping reduce energy consumption in the future. Some of the challenges that we face are that there are complex relations among the performance factors that I previously mentioned, and we haven't even mentioned all the different performance factors. There are other performance factors like modulation in wireless transmission and quantization parameters in video encoding and compression. We haven't fully studied those relations yet. There's another challenge we face is that the operating system, which in our case is Android, has certain security considerations or concerns that won't allow us to access all the performance factors to study them. And finally, the third challenge that we face is that we haven't considered other energy resources and how this will affect our optimization and our app. Other energy sources like perhaps solar power for mobile devices or other alternative sources that are being researched currently. So energy conservation, or our project, has significant impacts and benefits. I previously mentioned several services and businesses that can benefit from energy conservation in video streaming. But so as you can see in this graph, over the past 30 years or so, the CPU performance, which is CPU performance has increased drastically, and wireless transmission bandwidth has increased drastically. However, battery energy density has not increased as quickly. So by conserving energy, we can help to try to bridge that gap. We will validate our findings by comparing a video streaming without our algorithm and a video streaming with our algorithm, and we will compare the quality of the two videos. Then we will keep the quality of two videos same and compare the energy consumption of a video streaming with our algorithm and a video streaming without our algorithm. Now we will demonstrate our app.
Hi, this is a video of our app, a demo of our app rather. So you can see my phone here. We start off by starting up PowerTutor to log the data. Okay, now PowerTutor is logging data. Then we go to SwiftDroid, and this is the default screen for SwiftDroid, which we've modified. And you can see this IP address here. This is the IP address we use in VLC to start streaming the video. So now we'll go to VLC media player. As you can see, I have the IP address entered. Going to start streaming. So now you can see in SwiftDroid in the preview screen, we're streaming the video from the phone's camera, as you can see on the computer monitor. And once we're done streaming, we stop the video. VLC media player will save it. And once we're done with that, we can quit SwiftDroid. We stop logging in PowerTutor, and then we can save this log, and what that will do is save a log to the phone, which we can upload to the computer and parse for relevant data. And you can see this data here. So we have, this is the data for the 15 FPS video. We have the battery level, the Wi-Fi power consumption, the signal strength, and the PSNR. And here's that same data for the 24 FPS video. And on each of these tabs we have the comparison graph. So right now we are on battery level comparison. See, column A is the data for the 15 FPS video, column B is the data for the 24 FPS video, and that's injected into this graph. As you can see, the two lines comparing the two sets of data. You have the same thing for the power consumption. You have the column for the 15 FPS video, the column for the 24 FPS video, and that's inserted into this graph. And we've done the same thing for the signal strength. So you have the two columns, and this graph is created from those columns. And again, the same thing for the image quality. The image quality was created using the PSNR was calculated using a tool called Image Magic to compare the destination video frames to the source video frames. And that's it for our demo.